There's a time and a place that people used to sing to water, they used to take care of the water, they used to help water systems rather than to treat it as a commodity to continue to misuse and abuse water systems. My grandma's always said, you have to go back to nature. You have to go back and try to fix things, not plunge ahead and continue to make something work that is already broken.
Good evening, everyone, and thank you so much for coming to our panel today. We're going to be discussing a very important topic: water. Too much, not enough, and not safe. And that is a story for too many people on this planet today, and it's something that should not be, and for many, many situations, doesn't have to be. So we have a very interesting panel. My name is Regina Valdez, and I'm coming to you with the Climate Emergency Forum. To my left is Paul Beckwith, who's also with the Climate Emergency Forum. He's a climate science educator. And to his left is Dahlia Sabri. She's an expert in water resources engineering. She's also director with the International Water Resources Association. And to her left is Caleen Sisk, who is spiritual leader and tribal chief of the Winumim Wintu tribe. For too many people, water is become a daily drama and a daily disaster. The monsoons in Southeast Asia, which have been a regular part of the life cycle for many, many generations, have now been completely thrown out of whack. The monsoon season is now beginning earlier. It's much more profound and ending later, leaving fields inundated, cities decimated. At the same time, we're seeing a great deal of drought throughout the world as well. Of course, this includes the most vulnerable, those in sub-Saharan Africa, but I would be remiss if I were to leave out the western part of the United States. In fact, 2/3 of the United States is under water shortage, and the far west, namely California, has been under drought conditions for decades. Well, the multinational farmers are able to get all of the water that they need for their very thirsty crops. A lot of those crops include grain such as alfalfa that goes to feed livestock. That's grain that is imported, once again, to feed livestock, which continues the cycle of the problem, because more livestock means greater deforestation. Greater deforestation leads to more flooding and inundation, and the cycle continues. So we're going to look at what has happened, what we can do, what we can expect for our future, because as we all know, water is life, and without water, there is no life. So I'm going to go ahead and turn it over to Dr. Peter Carter. I believe we're going to be hearing from him via recording.
My topic is climate change and water. What could be more important? Too little water and too much water, and they're both increasing. This is extraordinary Northern Hemisphere drought in October of 2022. Europe, first week of October 2022, still in drought. The United States, 25th of October 2022, still in severe extensive drought. A 2021 report by the World Meteorological Organization on global water stress. The map shows the very many, very large regions of populations affected by water stress. The report said that water-related hazards like floods and droughts are increasing because of climate change. 40% of the world's people are affected by water scarcity. 2021 saw the continuation of extreme water-related events. This is a 2020 paper on the increase of the very costly floods worldwide. The larger the circles are, the more are the flooding events. And the quote from the paper, both the frequency and losses from global flood events have been escalating sharply, especially over the past 3 decades. This 2021 paper is called Global Flood Risk Map, expressed as the average population displaced 1980 to 2020. The huge population that has been impacted the most by the floods is South Asia. And you can see China, Japan above China, and then the other countries including India, Pakistan, Bangladesh, Thailand, and Vietnam. United States and Latin America, South America. Disastrous floods in Europe. Practically everywhere has had severe flooding with loss and damage and loss of life. Flooding damages agriculture. This is the sixth assessment of the IPCC on drought, soil moisture change, and there's drought at 1.5 degrees C and drought at 2 degrees C. You can see from the two maps there's a lot of shades of tan and shades of brown. And my conclusion on this is that severe, extensive world drought affects most major food-producing regions at 1.5 degrees C, and the drought becomes more intense 2 degrees C. Made it simpler here. I've divided it up. This is 1.5 degrees C. Similar projection by the AR6 on increased precipitation, 1.5 degrees C and 2 degrees C again. My impression is that at 1.5 degrees C, most of the world land is affected by heavier rainfall. Correlating projected increase in rainfall with present-day rainfall, we find the following regions will have the most rainfall, actual rainfall at 1.5 C. Arctic, Greenland, Siberia, Central Europe, East and Central US, Argentina, Northern China, India, Pakistan, the Sahel, and Antarctic. At 2 degrees C, the regions are the same, but the rainfall becomes more intense in a lot of those regions. I must mention here that the Asian monsoon is projected to get heavier and more variable, and it looks like that may have started already. You'll notice that in both cases that the Sahel has a lot more rainfall. One of the most heavy regions for precipitation is the Arctic, and it's huge, and that has grave implications for thawing permafrost, methane feedback emissions, melting sea ice, and melting Greenland ice sheet. This is the IPCC AR6 on flooding, on river flooding, and the shades of blue indicates more frequent flooding, though the increase in frequency is also associated with increase in intensity. Here you see that the entire region and the vast population of South Asia is affected by increased river flooding, and it will continue to increase. This is at 1.5 C. There is a difference at 2 degrees C. More of the United States is involved, and a lot more of South America is involved. So at 2C, practically all of South America is involved in increased flooding. Let's remember how damaging flooding is to agriculture. So this is our world at 1.5 degrees C, a world of increasing drought and increasing floods. We will be at 1.5 degrees C around or soon after 2030.
So a distant thank you to Dr. Peter Carter for that presentation. And I will turn it over to Paul Beckwith. Paul?
Yes, thank you, Regina. So I've been using the term abrupt climate system change for many years to describe our climate system, because our climate system is really broken, and it's not in a linear fashion. You know, our brains as humans tend to think in linear terms, but this is highly nonlinear changes that are occurring, sometimes exponential, and there's lots of feedback effects in the system that are making it even faster, the changes. So basically, our climate system is broken. So Peter has given us a good overview of the droughts and the floods and the general turmoil that is happening with his maps and graphs. So I'm going to talk more to the root cause of why this is happening. And the biggest factor is that the climate system is broken. And what I mean by that is there's great uneven heating of the planet. So high latitudes are warming much faster than lower latitudes. In fact, the Arctic is warming. The latest peer-reviewed research is finally saying closer to the truth, which is 4 times faster than the global average. If you go to the high Arctic, it's more like 8 times, but they've always been saying 2 times for many years, and they finally are saying, up their number. This uneven heating is also occurring in many systems. So, for example, the northern hemisphere, the heating in the air is more than it is in the southern hemisphere. So the northern hemisphere land is warming much faster. If you go up in elevation, the warming is much faster. So it's twice as fast at high elevations and low elevations. And also the land is warming at least 2 times faster than the oceans, even though the oceans are absorbing 90+% of the heat. They have high heat capacity, so you don't see the temperature rises as large. So all of this uneven heating of the atmosphere is causing the jet streams to fracture and be disrupted, broken. And this is greatly affecting the weather patterns around the planet. So the extreme weather events are increased in frequency, severity, and duration. And also there's a lot more variability. So from one year to another, you can go from extreme drought, record drought, to record rainfall amounts, then back to record drought in a subsequent year. You can also have huge swings on a shorter time scale, like 1 week can be extremely warm, next week can be extremely cold, and then back to extremely warm, setting records for the temperature highs and the temperature lows. So we're getting a lot more variability in the global weather patterns. I call it weather whiplashing, where you go from drought to flood to drought, and break all records in each of the cases. So, also we're getting extreme weather events in places where we didn't before. For example, torrential rainfall in deserts, or even snowfall in deserts, and areas that are normally getting lots of rainfall, like think of the Amazon rainforest region. We're getting droughts there, and once you get a drought started, it precipitates through the rainforest. So if you get a drought on the far eastern side of the rainforest, that can precipitate through the entire rainforest. Also, the way heat is transferred on the whole planet has been disrupted. I mean, we know the equator is warm, poles are cold, heat tries to move from the equator to the poles. It does so in the atmosphere and ocean, sets up the jet streams in the atmosphere. 2/3 of the heat is transferred in the atmosphere, and 1/3 is in the oceans, in the ocean currents. Also, we have these variable cycles called ENSO, which is El Nino Southern Oscillation. And we've been in a La Nina for the 3rd year running. So this has a big impact on what rainfall and you get in different regions. And once we get another El Nino event, which is a warm event, we will definitely surpass all previous global temperature records. So that's kind of the root cause. The whole system is disrupted. Now, there's lots of different technologies that people are trying. One area of a lot of research and breakthroughs is in desalination technologies. Typically, it's reverse osmosis or evaporative condensation systems, or high pressure water through filters. These desalination plants, of course, they are generally built near coastlines, and we have to make sure that they will withstand large sea level rise, because the melt rate of glaciers is greatly accelerating, like everything else with climate change, and we're going to get a surprise with sea level rise. And we've seen in the last year many major rivers around the world drying up. And these, stones are being exposed that weren't exposed for many years. So we're getting all of these cascading effects on our hydrological cycle.
Thank you so much, Paul. And next up, we have Dahlia. Thank you so much, Dahlia.
Thank you, Regina, and thank you for inviting me. Actually, my presentation will build up on the previous 2 presentations. So it's no surprise to know that the climate change is one of the main reasons behind the global water crisis. The UN has estimated 1.8 million people will and live in water-stressed countries in less than 10 years. So we need to know what is the story and what's most likely we feel now the extreme weather events. We feel that we have more drought and more frequent flooding events. So we need to understand how can we have, for example, flood and still we don't have enough water. In some countries, as Dr. Carter showed that in India, for example, in South Asia, they received so many rain events. However, the infrastructure is not well maintained, and they have the modern infrastructure. They paved the roads, and most of the forest and grassland disappeared, which affected the percolation of groundwater, and adding to that, the more runoff, and which caused more flooding. The shallow aquifers and deep aquifers have been depleted from abstraction. However, as time progressed and the population of the communities have increased, we see that most importantly, the roads have started to crust it up due to pavement. There is an increase of modern infrastructure, which means that water is not percolating downwards into the ground anymore. So the communities are getting thirstier and they don't have enough water. So what we will do about this, we would assume that we will maintain our groundwater tables. But what happens is that people as doing business as usual and abstract more water from the groundwater aquifers, which is getting depleted with time. And when the groundwater is depleted, people start to construct new wells and boreholes, and they are not getting water at the same depths anymore. So, for example, they used to dig groundwater wells on 80 feet, but now they cannot find water at 80 feet level. They go deeper and deeper till 2,000 feet in depth. If we try to see the whole picture and what this has resulted in, that the shallow groundwater aquifers have been demised, and this will represent the main source of drinking water for the communities, for example, in rural areas. So on daily basis, if you are pulling out millions liters of water from the aquifers and you're not putting back into the groundwater, this will result in depletion of the aquifers. And think of it like a bank. If you're withdrawing money every day from your bank account, year on year, you will not have enough money in your account. So it's but obvious that our aquifers will deplete, and flooding also has impacts on the ecosystem, as it introduces toxins to the surface water bodies, which already receives also waste disposal from human activities. So groundwater is threatened by unsustainable abstraction and contamination, which is contradicting with the SDG 6, which is calling for ensuring water and sanitation for all. If we look for the women and girls, they are the most vulnerable to the climate change, because they consider water is a women's issue, and they are responsible to provide natural resources to the households. So women, if they don't find water close to their home, they travel so far away to find water. UNICEF estimates like 200 million of hours per day women travel to bring water to their households. So we need to stand up together and work together to provide women with more wells close to their homes, to prevent any troubles they face when they travel to bring water, like harassment or any life-threatening attacks from anywhere. Thank you.
Thank you so very much, Dahlia. And next and last, we have Caleen Sisk.
Hestam Chalit, Ukawin Elowi, Pudum, Salwa Mim. I'm going to talk about the sacred water here. that for, forever, water is life. And the world right now has not been treating it as life. It's been making some decisions that should not have been made. And just in some of it is like in agriculture and the discharge from agriculture and orchards into the river systems, contaminating the very water that other people are relying on to drink. But, making snow on our mountain, they make snow, which causes the actual snow to melt faster because of the content in that snow has aluminum in it, and it heats faster in the sun. And so the snowpacks have vanished. Water bottling everywhere around the world, they're allowing the bottling of water, which means they're contaminating half of the water they're taking and then giving people disinfected water to drink as pure water. People don't even know what water tastes like anymore because of all of the chemicals that they put in it to preserve it or make it better, they say. The riverbank capturing, which they said there was flooding. To control the flooding, they put our rivers in levees and no longer let them meander. The meandering of a river allows aquifers to get the kind of water that it needs to continue to produce water in the way that the fish and everything else needs it. Tree cutting, we had the wildfires and now they want to cut all the trees down because they say they're having too much water, yet they're not really looking at the hydrological part of trees and how it brings water up in the mountains, and that the mountains really are the water tanks of the world. They're not the reservoirs. The reservoirs act as water warming traps, and the more water is warmed, the worse it gets, the more it evaporates. So the dams and reservoirs are there for flood control, and people look at those as whether or not we have water, instead of looking at the mountain and knowing whether or not we have water. Traditional people look at the mountain and the snowpack and the rivers and the springs to see if we have good water. Wildlife extinction also weighs in on water and how it's treated. There are wildlife that produces necessary things for the water beds, for the river beds. The salmon in our area are water climate changers because they clean the bottom of the riverbeds. They're not just a food source, but they're a source that helps protect the water systems so that groundwater and rivers can work together to make sure that there is water coming up for all living things. Traditional conversations with all waters need to be continued. There's a time and a place that people used to sing to water, they used to take care of the water, they used to help water systems rather than to treat it as a commodity to continue to misuse and abuse water systems. My grandma's always said, you have to go back to nature. You have to go back and try to fix things, not plunge ahead and continue to make something work that is already broken. So Mother Earth will survive climate change, but a lot of people are not going to. We have that chance now to make that difference, to make that change. And if we would take that in reality, we're here at COP27, where the countries are talking about 1.5 degree change. Off zero. 1.5 off zero is still disaster in many parts of the world. Until they start focusing on zero, this isn't going to make the difference for many people in the world. And a lot of the other people who are in flood areas, like in New Zealand and some other different islands, are going to suffer first. A lot of the people who are not able to purchase water because the prices are going up. Even here at this COP, it's hard to find water here. and we should have water available to everybody who has come here. So at the closing, I'd just like to sing this partial song just as a parting, and it says Salwal Mayomes, which is the sacred water. Salwal Mayomes Beles Bom, Salwal Mayomes Beles Bom, Pihat Bohe Wintun Toad, Waiken Legas Knees. Woo! So thank you for letting me hear with this water. Oh.
Thank you so much, Caleen. That was lovely. Thank you all for being here on this very important topic. I appreciate what you had to say about going back to nature. And I think a big part of going back to nature means living where it's natural for us to live. For example, we're in a desert right now, and as Caleen said, it's very hard even for us here to get water. When we live in places that don't have a water source, we have to bring it in somehow. And too often that means bottling water, purchasing water, commodifying water. These are just things to think about as we close out this session. And I'd like to offer a special thanks to the Sustainable Population Australia and also International Society for Ecological Economics and all of you in the audience. Thank you.